Hello, everybody. We're going to start talking in this chapter about one new topic, which is the chemical reactions. This topic is going to be very related to the previous two chapters. So we talked in the chapter two about the periodic table and the periodicity of elements, the properties of elements. And in chapter 3, we talked about the bonds that form between the atoms, depending on, and we related this to the position of the atoms in the periodic table. And here we're going to talk about the reactions that lead to the formation of these bonds. So it's going to be very related to the previous two chapters. And we're going to talk first about some terminologies or some or revise quickly on some things that I believe will be important for us to be fresh in our mind, so that we don't have any issues with dealing with the with this topic. So the first thing that I'm going to talk about is the free radicals. And free radicals is either an atom, a molecule, or an ion that contains at least one unpaired electron. So these radicals act as one single unit. They are reactive, so they can go easily into reactions, and they behave as a single unit, as I said. So we know a lot of them. So it's like ammonia, like hydroxyl group, like nitrate, like sulfate, sulfide, bisulfite, perchlorate, chlorine, chloride, iodide, bromide. So there is a very like a big set of free radicals. The majority of the free radicals are negatively charged, and some of them, which are not too much like ammonia, are positively charged. So this is something that's very familiar. So I think, or I mean, it's very common. So I think everybody will be familiar with these free radicals. Um, there's the other point is the acids, and we talked about the acids before. And usually the definition of the acid is that it's a compound that can produce hydroxyl ions in aqueous solutions. So think about any acid like sulfuric acid, hydrochloric acid, or any kind of acid. So when it's in water, it produces the negative ion and the H3O ion. What happens here is called ionization, that the acid is broken into the ions, and the degree of ionization is different from an acid to the other. So not all the acids produce the same amount of hydroxyl ions when they are in the aqueous solution, and this kind of is the reason of the strength of the acids. So the not all the acids are of the same degree of strength. So we will have, for instance, something like the carbonic acid. The carbonic acid is a very weak acid, and we actually drink it in soft drinks like Pepsi, Coca-Cola, and stuff like that. And carbonic acid is weaker than H2S. H2SO3 is weaker than H3PO4, weaker than nitric acid. HCl is weaker than sulfuric acid. So there is a kind of change of or different levels of strengths for acids. The second or the third, or let's before moving forward, this is like a nice video for um, tissue, roll of tissue paper, and this what happens is that the acid, I think it's sulfuric acid, was poured on it, and as we see, the acid starts to react with the tissue paper. It dissolves the drawing that was there on the tissue paper, and as the time goes, you see that the reaction proceeds, and the tissue paper starts to get darker and darker. So it's kind of getting burned by the acid. Some fumes are getting out of the tissue paper, and it's now getting more and more aggressive. It's just like burning the tissue paper. So and that's why dealing with acids must be done with precautions. So you make sure that you wear the goggles on your eyes and the lab coat. You wear gloves so that you don't have any issues or you don't get hurt when you work with acid. The next is the base, and the base is generally applied to the metallic oxide. These metallic oxides, if they are soluble in water, they form the alkalis, which is the hydroxide. So this is the alkali, and this is the M plus, which is the ion that is formed, and it produces the OH ions in water. So acids produce hydronium ion, and the alkalis produce the hydroxyl ions. Example are sodium hydroxide, potassium hydroxide. Any hydroxide is an alkali. The salts are the product of the reaction between an acid and the base. This reaction is going to be discussed in the next or the next video or the video after that. So the reaction between acids and bases produces salt and water. So it's like silver chloride, sodium chloride, barium sulfate. Anything that is composed of a negative ion and a positive ion is going to be a salt. The last thing is the pH, and the pH is a measure of the concentration of the, or it's a measure of the acidity or the alkalinity of the solution. It's always, or it's calculated by this using this equation. It's negative log the concentration of H plus ions. And to understand this, why we use this equation, usually the concentration of the hydrogen ions in the solution are in the order of 10 to the minus something. So it's like 2 multiplied by 10 to the minus 2, minus 3, minus 4, whatever the number. So it's not going to be convenient to write 10 or a number multiplied by 10 to the minus whatever. So what we want to get is the power, because it's going to be an easy way to indicate the concentration of H plus ions. To get the power, we get the negative log of the concentration, so you get a positive number that's ranges from 0 to 14. And as we see, the 0 is the maximum concentration of H plus ions, because we have the negative log here, and the 14 will be the minimum concentration of H plus ions. So this is the most alkaline place on the scale, and this is the most acidic place on the scale. So here we see the strong acids, and then you go and see the lemons, the apples, the tomatoes, and then water in the 7. When pH is 7, it's the neutral value. Here we see the baking soda, we see blood soap, and at the end we'll see the drain cleaner. So in the next video, we're gonna start with the chemical reactions. We're gonna talk about this list of reactions: direct union, decomposition, neutralization, hydrolysis, displacement, precipitation, and oxidation reduction reactions. We're not gonna go into deep details. We just wanna know how this reaction is defined, or how we can tell if this is direct union or neutralization or hydrolysis, whatever. We will know the differences between them. Yeah, this is all for this video, so we'll see you next video, inshallah. Goodbye.